This is the next in a series of videos of HRPToF data. I just finished fitting my data to HRPToF just finished fitting my high-res PToF data and subtracting, and I'm ready to plot the results. I am going to select in my drop-down box now. I'm going to select Get List, and I notice I have some new items here. I have something called PToF DC1 stick. That's my region 1. This is my matrix. This is my region 2. And this last one is my matrix subtracted from my DC1 stick. I'm going to select that. That's the one that I want. And I'm going to go ahead and plot my average size distribution for my all-to-do wave. Boom. Here's my results. And now just to compare that to my unit mass resolution, I'll go ahead and change this to about 20, and we're going to go from, we'll say, 50 nanometers to 5,000 nanometers. That's pretty big, but let's go ahead and do that real quick and compare the two. Of course, I could plot these on top of each other. Now, these are very similar. The magnitude is not quite the same, and that is because of some air species, and we'll talk about that in a little bit. I could have opted to append this on top of this other graph. I'll leave that for you to do at home. You will notice a couple slight changes. Here I'm getting a little more ammonia, and that is because I can fit actually ammonia in my high-res PToF better than I can estimate it in this graph over here. So this demo is about talking about some of the features, so I just want to show you a few other things. We have two checkboxes here that are similar to checkboxes here. The scale to MS data, and this is going to scale to my high-res data now. So for example, if I wanted to plot some of my favorite ions, C2H3O and C3H7, these are the two main ions at mass to charge 43. I can go ahead and plot those, and let's go ahead and do that real quick for fun. And I can, this data is a little bit boring in that I'm not seeing much difference in the size range between these two, but I'm getting these as different ions here. Let me throw a legend on there so you can see that. This is not possible with UMR. Obviously, we can't separate these two in UMR. And I can do find and display mode and medium stats just like we did over here. So let's just do an image plot here for these two ions, and now I'm able to see a few slight changes in time. This is my time axis. This is C3H7. This is C2H3O, and I can see here's my high resolution time series. Here's C3H7 and here's C2H3O, and so there's differences not so much in the size dimension, but in the magnitude of these different ions over time. So here's where some fun science can actually begin. There's a couple other features you will want to use. One is this review bin time. So as you're looking at some of these PToF bins at different sizes, you may want to know the different time in PToF time that it corresponds to, or the diameter. So now this is the diameter of the very first bin corresponding to here in nanometers. So this one is going from 48 to about 67 nanometers, and the next one 67 to 87, and so on and so forth. I can generate a three-dimensional matrix of runs and bins, new PToF bins, and mass spectra through this button. I'm not going to do that right now. And then there's this handy little panel that brings up this this